Good day to all of you. Today we shall discuss on model question paper 1-2023-24 of the subject Digital Design and Computer Organization with the subject code BCS302. In that question number 2a, demonstrate the positive and negative logic signal. It carries 5 marks. Solution. So before going to actual discussion, let us see to these figures first. So this is figure A, which is showing positive logic, figure B, negative logic. So in these two figures, it is showing signal assignment and logic polarity. Okay. And one more figure is given here, that is figure C, signal values. Right. So HL, these are signal levels. Okay. So in signal values, this figure, here we can see along y-axis 0 volts, here 1 volts, here 3 volts. So in the field of digital electronics, voltage values, that is DC voltage values from 0 to 1 volt, in between this, that is called as logic 0, and from 3 volts to 5 volts, that is called as logic 1. Okay. So to be called as logic 0, that DC voltage value must be between 0 to 1 at least. To be called as logic 1, that DC voltage must be above 3 volts till 5 volts it is, not below 3 volts here. Okay. So with this background, we shall see in digital circuits, the inputs and outputs of any gate has one of two values, logic 0 or logic 1. So in digital system design or digital electronics, what are the building blocks? Logic gates. They are made up of transistors, right? So at inputs, any number of input can be there for a logic gate, starting from 1 to, okay, multi-input logic gates, we say one input logic gate. Any number of inputs will be there, but output always it is 1. And how do we state inputs and outputs? We state the inputs and outputs in the form of logic 0 or logic 1. We say that input is at logic 0, output has come out to be logic 1. So we do not speak in terms of values, signal values, like 1 volt, 0.8 volts or 3.2 volts or 5 volts, 3 volts. We speak in terms of logic values, whether it is logic 0 or logic 1, not signal values. Okay. If that DC signal value is between 0 to 1, it is logic 0. Above 3 and to 5 volts, that is logic 1. In general, we call 0 volts as logic 0, 5 volts as logic 1. But this is the actual scenario. Okay. So next, in both positive and negative logic, input and output signal levels are same, but only logic values assigned are different. Okay. Logic levels or logic values. Logic level or logic values means only two, logic 1 or logic 0. In both positive and negative logic, input and output signal levels are same. So seeing to figure A, it is positive logic signal assignment and logic polarity here. This is for negative logic, that is figure B. So if you observe this figure for positive logic, what is the signal level? It is high, means above 3 volts it is. Okay. What is the signal value here? Low, that is 0 to 1. So these are these signal values, or they are indicated in the form of high and low levels here. Then what is the logic value or level assigned to this? So here signal level, that is L, is assigned logic 0. So low level of voltage is assigned logic 0. High level of voltage is assigned logic 1. So logic 0 for low level voltage, logic 1 for high level voltage, that is in positive logic. But in negative logic, low level voltage is assigned logic 1 and high level voltage is assigned logic 0. just the reverse of this. This is positive logic, negative logic. The signal levels are same. High means above 3 volts, low means 0 to 1. They are same, but assigning logic values are different. Here 1 for H, 0 for L. Here 0 for H, 1 for L. Okay. So figure AB in positive logic signal level H, that is high, is assigned logic 1 and L low as logic 0. It is just reverse in negative logic. Figure C shows signal values 0 to 1 volts as logic 0. 3 volts onwards till 5 volts it is logic 1. But in general in digital electronics, how do we speak? Logic 0 means 0 volts. Logic 1 means 5 volts. Okay. So in digital circuit, H and L means not values but levels. Levels H and L are same in both positive and negative logic. But assigning logic values 0 and 1 is different. Signal levels, voltage levels are same, but assigning logical value 0 and 1 is different. If we take an example, here is a truth table. So in this truth table, what is written here? This is inputs X and Y. This is output Z. So there are 4 combinations of inputs. L, 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 H, H, L, H, H. So when both are L, output is L. When any one is L, output is L. Only when both are high, output is high. So this represents a behavior of a digital gate. Okay. But which gate? So this truth table, if you write with positive logic, L is written as 0, H is written as 1. Okay. So when both are L, L, output is L. When both are 0, output is 0. When any one is L, when any one is 0, output is 0. Only when both are high, only when both are 1, output is 1. This is definitely the truth table of AND gate. Okay. For this truth table, then the digital gate is AND gate in positive logic. So same truth table in negative logic, if you take, L, L means 1, 1. Okay, for L, L level of signal values, logical values are 1, 1. That is in negative logic. So L, H means 1, 0. H, L means 0, 1. H, H means 0, 0. Take the output. L, L, L means 1, 1, 1. H means 0. This truth table is as referred in negative logic, that is written here. Then which gate is this? So when any one is 1, the output is 1. So here this is OR gate in negative logic. So to indicate that it is OR gate, okay, this symbol, to tell that in negative logic, these marks are used here. The same truth table, but levels when interpreted in these signal levels when interpreted in positive logic, what is the digital gate? In negative logic, what is the digital gate? That is what is making the difference here. Signal values or levels will be same, but what logical values are assigned to that is different in positive logic and negative logic. In positive logic, low voltage means logic 0, high voltage means logic 1. In negative logic, low voltage means logic 1, high voltage means logic 0. Okay. So that completes the discussion of positive and negative logic. Okay. I hope you understood. Thank you.